So how are we going to get the feeling of a 3D movement on a 2D screen? Well, we're not going to be able to get it with a single point. If we get the single point moving about in 3D space, and you take a snapshot from one angle, there's no way for you to tell that that is actually moving in a 3D space, unless of course we have some perspective, meaning that it gets smaller as it goes further away and it gets larger as it comes towards you. But we haven't worked that into these equations yet, so we don't have that. So we've got no way of knowing whether the point is actually moving in a 3D space or whether it's actually just moving in a single plane. Now, the only way to create the feeling of movement in that space is if we look at more than one point. And in fact, it's much better if we look at, say for example, a line or a plane or a 3D object. So we'll start off by looking at a line. Now you've got access to this simulation and you can open it up yourself. Now there's nothing new in animation or images. The inputs here, I've just slightly changed the naming convention here. So the inputs are just given by the X, and it's maybe a bit small here, but it's X and it's subscript I0, so I for input. So we've got I0 and Y0 and Z0. Now the reason why I've done that is because we're not going to just have one input point. So I've taken that there and I've made that point 0, 0, 0. So this is this point here, okay? So one of the points that is going to be rotating is actually the point which is the origin. So in effect, we won't actually see that rotation, it'll just be a fixed point. Now, there's going to be a second point now, so this is the second point up here. So the second point is given by the input X input 1, Y input 1 and Z input 1. And I've given that the point 2, 2, and the Z is just given by a value of 0. So if we continue down, you'll see that we've got the points here. Now I'll bring the points up. So that's a point here in the origin, and I've got the point at the far end here. But we don't necessarily need to have the points on, so we can take those off. So that's the inputs. Now it means there's going to be two sets of equations. Now we're not always going to be continuing in this vein. We are going at some point to simplify it and look at a more elegant ways of writing this, but it doesn't matter for the moment. We just want to get something up and working. So we've got the two sets of equations which we've seen before. So we've got our, now the output is going to be called XO for output. So we've got XO0, YO0, and we've now got the second set of equations which does it for the second point. So the second set of equations are going to give the output for X output 1 and Y output 1. So there's nothing really exciting or interesting there. I've just simply copied the equations over and we're doing the rotations for a second point. Now whenever we do the plane and look at also a 3D object, we'll just extend this and we'll just add in more and more points to create a shape. Okay, so not the most elegant way of doing it, but it's a start and it gets us up and running. So in order to join the points together, we can join the points together with a line. So in order to do that, we can click on plus and you'll see there's a thing called a table. You click on the table, then you can just put in the endpoints. So you can put in 2 points. So for example, a point x0 and a point y0, so that's 1 point, and then you could do say x1 and a point y1, and it's got those 2 points. In order to join a line to it, you just click on here and you can click on line and it will draw the line between those 2 points. So that's how we're going to generate our line. Now these are the same, we've just got our angles, so we've got our angle beta in the Z direction, an angle gamma in the X, and an angle alpha in the Y direction. So let's go ahead and we'll see this working. We're going to rotate the line round about the Z axis. Okay, so let's see it just rotating round about. Now we're going to rotate it round about the x-axis, and we're going to rotate it round about the y-axis. So now if we do all three axes at the same time, then we should get something that looks like a pencil, if you like, rotating round about in a 3D space but mapped onto a 2D plane. So there you go. Now, in effect, what we've got there then is the line there, which is actually, luckily enough, it's the same colour as my pencil. So the line is just represented by this pencil here, and we've got a fixed point over here, which is the origin, and this end is just rotating round about. So that line there in our computer screen is modelling what we are doing just now with this pencil. And of course the interesting thing is that you know that I'm rotating this pencil round about in 3D space. Your brain tells you that that's actually what's happening here. And you can see how it just models and looks just like what we have in our simulation. So that's our first little foray into getting something that looks like a three-dimensional movement placed on a two-dimensional space. So let's go ahead in the next video and we'll put in a few more points. So we'll do it with a plane, and then we'll do it with an actual 3D object.